I got one. I got one, guys. I got one. An air conditioner. Guys, welcome back to the off-grid garage here in the sunniest and hottest Australia ever. It is like 35 degrees already. Probably 11 o'clock in the morning and it is so hot. But welcome back. Before we actually start today's show here and I'll show you the air conditioner I bought, can I just have a quick word to my German viewers? I mean, everyone who understands German, just so in private, okay? So just come back in 30 seconds. Ja, da werden einige jetzt erstaunt sein. Aber ich habe noch 2 andere deutsche Kanäle hier auf YouTube. Und viele entdecken mich erst jetzt auf diesen anderen Kanälen. Also will ich mal ein bisschen Werbung hier für mich selber machen. Da könnt ihr mal vorbeigucken hier auf Andys Garage und auf Living Down Under. Da geht es jetzt aber nicht so um Solar- und Batteriekram. Also das ist mehr andere Sachen, die wir hier in Australien machen. Wenn ihr daran interessiert seid, guckt doch da mal vorbei. Da haben wir auch eine schöne Community, haben wir immer Spaß. Und alle meine Kanäle sind schon immer unter den Videos verlinkt. Naja, so nach und nach finden mich die Leute. Also, wenn ihr Bock habt, guckt mal vorbei da, sagt Hallo. Und jetzt geht's hier weiter in der Off-Grid Garage. Geh mal wieder rein, komm. Enough advertising, let's get back to the topic. Yeah, sunny hot, right. So let's have a quick look on the dashboard first. I have the DVCC still activated here on my system, so the overall charging current for my DC load and my battery charging is limited to 50 amps altogether. 20 into the batteries and 30 amps. Well, 30 amps goes into the XIA inverter, which runs an extension cable all the way back to the house, and we have plugged in the air conditioner inside the house now. So this is 100% coming from the battery as well. And this is what you can see all the time in the DC system, 1.6 kilowatts around, 31 amps. Because I wanted to wait until 10, 11 o'clock before I turn on the full system, unrestricted charging, unrestricted power from the solar panels, to get the maximum heat in the system here, so we can actually test the air conditioner and see if it makes a difference and if it makes sense at all to have an air conditioner running here in the garage, where all the garage doors are open all day long and it's not insulated and nothing, and totally crazy to think about it. West roof controller 40, 39, 38, yeah, around 40 degrees we have. So let's measure the temperature here as well. 40.1 we have, and the main circuit breaker has 31.7. Let's go and turn off the DVCC. Just turn it off and go back and unleash the beast. So 3.4 kilowatt at the moment, 20 amps into the battery, and this should change in a second. And then we should see maximum output of the solar. Here it comes, it's ramping up. 10.5 kilowatts. Okay, so I guess we leave this running for an hour or so, and then we measure again the temperatures here on the solar charge controllers. But I'm sure we will see temperatures above 50 degrees, 55, maybe even 60. It is hot. So now we've got 160 amps going into the battery, and we will see the battery heating up as well. 30 degrees at the moment, 36 outside, 29 inside the garage here. The vehicle's battery is on 50%, we can give it another 10. Because if I don't use the car, I usually keep the battery at about 50 to 60%. It gives me 175 kilometers at 50%. So this is all I need anyway. And now we should see the AC ramping up here as well. 2.4 in the car and 600 watts for the pool pump. Yeah, we are close to 12 kilowatts and still 120 amps going into the battery. If I would just charge the battery now without much load being connected at the same time, it would be full in about 2 hours. That is crazy, right? 50% state of charge battery, 44 kilowatt hours. Shortly after noon, battery would be full. Yeah, probably I can connect a bit more load inside the house. I tell you what, extension cables and power boards running from your garage inside your house is not good for your marriage. This can only be a temporary solution until we are fully connected here. It's not good, it's not good. Okay, so while the whole system heats up now, let's have a look on the air conditioner. Well, since the last video I had a look online, Facebook Marketplace, Gumtree, eBay, and you can buy these mobile air conditioners here for about $300 here in Australia. New, brand new. And then last Sunday I found this one here on Gumtree. And it was just posted, and I got in contact with the seller immediately and said, well, we will be in Brisbane on Monday anyway. Please reserve this one for me. I'll buy it. I'll give you some money right now. Do a deposit. Don't give it away. It's mine. And here it is. And because this is a very special air conditioner, I was looking for a small unit only with about 700-800 watts and around 2 kilowatts of cooling power. But this one here has 1400 watts electrical and 4 kilowatt cooling power. 4 kilowatt. Yeah, I'll take it. And what is so special on this one here? It is a portable reverse cycle air conditioner. So this one can not only cool, it can also heat. Yeah, it's a heat pump, works in both directions, cooling or heating. And I thought this is especially good in winter time here when it's freezing cold here inside the garage and I'm making videos here. It can get under 15 degrees Celsius inside here. I mean, this is just, whew. Comes also with all the hoses and the window board and also this plastic hose here for the water drainage. And it pumps the water out automatically, so you can just go outside in the driveway somewhere, it doesn't matter. Where is it? Where is it? Here. Here is it. Cooling capacity 4.1 kilowatts. Heating capacity 3.5 kilowatts. And the input power is 1.4 kilowatts. 36 kilos. And to be honest, it looks really good, you know? I've seen so many air conditioners online now and they were all yellowish and everything and faded and the plastic was dirty and parts were missing or something was broken. And this one looked really good on the pictures and I saw it and I said, oh, this is exactly what I want. This is exactly the thing. It has even this filter we can remove. They cleaned it all out for me. It's a washable filter. And there you can see the air conditioner coils. Water drain if you don't use the hose. This is your hose connector. There's actually a small switch in there, see? Hear that? And this tells the air conditioner there is a hose connected. Once the small tank fills up inside, it turns on the water pump and pumps out the water. And then it goes out of the driveway. And I paid only $125 for this unit, including all the accessories. Everything included. A portable reverse cycle air conditioner. What? Okay, let's turn it on and see if it works actually. I haven't tested it yet because it was lying flat in the Tesla for about 2 or 3 hours. And I left it since Sunday, so for the last 2 days standing upright, just so the compressor oil can collect again and everything is good to go. But now after 2 days, it's ready to go. I'm so looking forward to it. Okay, let's do it, let's do it. So I plugged it into our power meter, and the standby current or standby power is 0.3 watts. So that's good already. I could hear it beeping. So I read the manual and it says, oh, open this one. This is where the magic happens here apparently. Can move this left and right. All right, let's turn it on and see what happens. Wow, it works. It's not cold. Takes a moment, right? Okay, so at the moment it's pulling 80 watts only. This is for the fan. This is for the fan in this is the maximum speed of the fans. But there's no cooling yet. I hope this bastard works. Whoa, whoa, something happened, something happened. And we are pulling 1.4 kilowatts, 1.4 kilowatts. Oh yeah, it's getting cold, it's getting cold, I can feel it. Guys, it works, it works. It is getting cold. Nice. Woo. Wow, it is actually pulling 1.7, 1.8 kilowatts sometimes. That's a lot of power. Maybe this one is a bit too big, huh? I had to put this exhaust pipe on it here because otherwise it sucks in the hot air coming out of this vent opening directly into the air conditioner again. And now it is a lot cooler on the outside. That's a 60-degree hot air coming out here, 60 degrees. Holy shit, eh? And I'm measuring directly here at the vent opening where the cold air is coming out, and it shows me minus 40 degrees. Jeez, that is cold. Well guys, don't tell me in the comment section that -7 or -10 degrees is cold wherever you are. We've got -40 degrees inside the garage. That is cold. It is nice. It is cool. I should probably hang a spat in front of it. So, and now it shows the room temperature, 30 degrees. So if we change this one and set this one to like 28 or so, you know. So I thought maybe for the test we can put this window board underneath the garage door, have the hot air exhausting to the driveway, and then have the air conditioning somewhere sitting here in this area and blowing the cold air in this direction to the power wall, the inverters and the battery as well. And then we want to see if this makes a difference actually, but we will leave this one running here for a while and see how it goes after an hour, and then we measure all the temperatures again, and then we put the air conditioner in place. -40 degrees. That is insane. Okay, so after 1 hour of running on full power here, when they launch rockets into space, is it not called maximum pressure on the vehicle or something? I think this is what we have right now here. So we should see close to 60 degrees temperatures now. Yeah, 58, 59, 55, 56. This one is cooler, 51, 53. Yeah, these are normal temperatures now under these conditions, running full power. 12.6 kilowatt from solar. This is what I usually see under full power, under full production. And we are charging the battery with 137 amps. So you can see the battery temperature has already risen by about 3 degrees to almost 34. 37 outside, 31 inside the garage. Let's do it. So the exhaust with the hot air goes now outside. I'm not sure how effective this is because the garage door is still open here. It's a bit windy outside today. And you can see there's still a big gap behind the roller doors to the outside. And we also have still a gap down there. Good enough for a test. Alright, let's do it. Whoa, there it comes. And quickly here we've got 40 degrees. And 37 on the main breaker. Oh yeah, I can feel it. So this is now blowing air onto the inverter, which produces the power for this device. And there's also a lot of air going this way towards our solar charge controllers and the rest of the power wall. I'm not sure. Oh yeah, we can feel some air going over here as well. So it actually cools down the battery compartment as well here at the top. So let's see if the actual temperature inside the battery compartment decreases as well over time. Oh wow, yeah, super hot air. I still can feel the cold air coming over to the workbench here. Ah, that is nice. Honestly, it doesn't feel cooler in here, but the air is somehow fresher. You can feel it's not as humid anymore. Okay, let me show you something interesting. Here in the Advanced tab, we can actually see the history from today. And you can see when we turned on the solar, turned off the DVCC and let all the power coming in unrestricted. So you can see here the solar charge controllers, they were all ramping up and producing as much power as possible. And this was the whole morning. All solar charge controllers were just idling with the DVCC still activated. And then here, 11:15, boom! So this is the temperature inside the garage. In the morning we can see a slow increase in temperature till 10 o'clock. And then when we turned on the solar, it got actually hotter inside and we can see a slight increase. So the curve actually gets steeper. And then at 12 o'clock, when we turned on the air conditioner, the curve actually flattens out and it doesn't get any hotter inside here anymore. And we can see something similar here with the battery. In the morning, a slow increase in temperature of the battery when the DVCC was still active. And then we unlatched the power and it charged 3 times, 4 times as fast as in the morning. So you can see the curve actually goes up. More temperature is being generated in the battery shelf. And then here at 12 o'clock when we turned on the air conditioner, you can see now the curve is actually going flatter again. So the temperature doesn't rise as fast anymore. And we are now at 36 degrees. We have started with 34 when we turned on the air conditioner. So only 2 degrees temperature increase in the battery. Even we charge twice as fast as, even we charge almost 3 times as fast as before. So we can already see a trend here, especially inside of the garage. And also the battery temperature is following along the increase in charging power, but then also when we turn on the air conditioner, we can see the slowdown in temperature increase. I have now lowered the vent opening a little bit here, so the air actually goes not as high anymore, and we can see an immediate effect here on this solar charge controller. It's down to 48. This is probably the better setting now. It blows a bit more air in this lower area here now of the power wall. Yeah, they're still at 40. They shouldn't be affected. Nice! So, and we have just hit absorption voltage of 55.2 volts. And here we can see we are at 44 degrees. 40. 38. 38. So from now on it only gets cooler here because the solar system is ramping down now, production. And we can see the solar is only producing 8.7 kilowatts, and this is going down quickly now. So we could maintain the 31.3 degrees inside the garage. Battery temperature has increased to 37 just now, but this will cool down now as well. 38, 32. Yeah, all the temperatures will go down now. We have just passed the peak performance of the system and it's ramping down.
20 minutes later.
We're now at 33 degrees, but the solar charge controllers are not doing much anymore. West roof 1.1, big shed 2.4. Big shed, come on big shed, 36 degrees, totally fine, nice. And we can also see the battery temperature went down by 0.2 degrees Celsius. So the whole battery shelf is actually cooling down now. Charging has stopped, but the air conditioner is still running. Okay, so well, I think this concludes the first test of an active air conditioner here in the off-grid garage, cooling down the power wall and the battery shelf. The only downside I have found so far with this air conditioner is when I disconnect the power, obviously the air conditioner turns off, and when I plug it back in, it beeps, but it doesn't start anymore automatically. It won't turn on. It is now waiting for either a key press here on the control panel, or if I press the on-off button on the remote control, it turns back on again and it's all good. Yeah, so because I was thinking of using one of these on-off switches in between so I can turn it off and on remotely, but obviously this doesn't work. Not a huge deal, because if we expect hot temperatures during the day and I'm not at home, I can either pre-program the air conditioner so it turns on after a certain amount of hours, or I just leave it running and set the temperature automatic to like 28, 29, 30 degrees, and it will turn on automatically once it gets hot in here. And it will be only for these couple of weeks during the year when we actually need the air conditioner in here. Because once the battery is fully charged, there is actually no need to cool any further, because everything will ramp down, solar charge controller throttle down, cables and fuses, everything is cooling down then, because we only supply power to the load but not charging the battery actively anymore. So quick verdict after this one test now. It seems to do the job. It seems to cool down the inverters as well. Even they need to produce more power, more additional power to run the air conditioner as well. But it has a positive effect on them. Yeah, and all the solar charge controllers are not getting as hot anymore. The cabling, the fuses, the junction box up there, and we can see the battery either slows down dramatically or even cools down now. And maybe if I push the air conditioner more in this corner and have the air coming from the side along the power wall, that could be I need to play around with the position and orientation of the airflow a bit over the next couple of days and see what works better or not so good. Well, if this will be a permanent solution here, I don't know yet. This is just something I test, because I thought if I put a big fan here just cooling the solar charge controllers, the rest of the installation will not benefit from that. On the other hand, I'm not a big fan of having an additional device here in the garage. I'm really running out of space here. Okay guys, I think so far this video from today, our first, it is so good we can share this experience together, you know. I've never tried this air conditioner before and we did it together. That is fantastic. Yeah guys, thank you so much for watching. Thanks for all your amazing support here on the channel. Thank you very much who has donated to the channel. And until the next video guys, when we do some more interesting stuff here on the workbench again, you stay charged, stay cool or warm. Most importantly, stay safe. And thanks again for watching. See you then. Bye bye. Nice. It's nice.